In this video, we will continue with inverse trigonometric functions. You will find this on page 207 in the Namibian AS-Level Mathematics textbook y equals mx+c to success. Let's look at another example, and this is a typical exam example. The function f is defined by fx equals 3 tan a half x minus 2. So there is the function. For negative a half pi, x is bigger or equal or x is smaller or equal to a half pi. So if you can remember from previous videos, I just want to show you, this is the principal value interval of the what? Of the tan function. Okay, so find an expression for the inverse and find the domain of the inverse. Okay, let's stop there. Find the expression for the inverse. Now, we don't have to do it again. I don't know why I'm doing it again. Okay, so how do we find the expression? We are going to make all, okay, first make this y, and then make all the y values x and the x values y. Okay, now take this one over. Then divide by 3. I'm sitting with this. And now I'm doing the same as I showed you in the previous video. I do the inverse. I swap. So I say tan minus 1. And did you see? I take this. I just want to take another color. This and this. And I basically just swap that. Okay. And then I'm just to get a half, I just multiply by 2. Both sides to get it 1y. And there is my inverse function. So the inverse function, and don't forget to write f minus 1x, is 2 tan minus 1 x plus 2 over 3. Okay. Now, the domain of the inverse is the range of fx. So we must first find the range of this one. So this is f. Remember, this is fx. So how do I do that? I substitute the limits. Negative a half pi and a half pi of the domain into fx. So just basically, in the place of x, just substitute the negative and press it on your calculator. And as soon as you see radians, make sure your calculator is on radians. So go mode, my calculator 2, now it's on radians. And now, if I must I would press, I'm just going to do it again. So 3 multiply tan bracket. And then 0.5 multiply negative 0.5 multiply shift pi, close the bracket, equals minus 2 equals, and I get that negative 5. So basically just start from the beginning and just press up to the negative 2 and you get 1. Now remember, that is the range, but the range is equal to the inverse, the domain. So basically I'm just saying, remember to put x, because, okay, let me say fx, the range will be y is bigger and equal, because there's a bigger and equal, to negative 5 and smaller and equal to 1. That would be the range. But that will be equal to the domain. But don't forget to scratch the y and just put an x there. Basically what you do. But the values stays the same. Okay, let's look at number B. Sketch on the same diagram the graph of y equals fx and y equals f minus x. So the function and its inverse. Okay, I'm going to make it bigger. I'm going to show you a few things here. Now, you already have these values. Okay, so let's look. Here's fx. You already have, when it was this, it was negative 5. Do you see? And if it was this, positive, it was 1. Now fill in a few. Fill in the middle, negative a quarter pi. Press it also on your calculator, approximate to 1 decimal place. Press 0, get this. Press a quarter, get this. Okay, so at least you have a few more values. Now, if I start plotting this, I read this. In this question, it's not necessary to label the axis. Then it's easier to swap the x and the y coordinates. Okay, so, but still I'm going to use, this is Okay, this is fx, but this is 0. They cannot change. This is 0. So if I'm going from 0, there is negative a quarter pi. So there is going to be negative a half pi. And I go down, negative 1, negative 2, negative 3, negative 4, negative 5. So I still make my 1 centimeter blocks. Okay. Then negative a quarter, and then I just approximate, this is going to be negative a quarter and negative, let's just see where it is there, negative 3.2 approximately here. And then it's 0 and negative 2, and then this is the quarter, and there it was approximately negative 0.8, and then there is a half, and it was up to 1. So the sketch is there. Now, you can even make use of now that you know it's a reflection in this, but you can still work on the same. So y equals x, it's going to be a reflection in the line y equals x. What you basically do now is you swap these two values around. The y becomes x and the x becomes y. Now look at how I plot it now again. I'm going to say negative 1, negative 2, negative 3, negative 4, negative 5. That's the reason I was not labeling it. Okay, now at negative 5, now this is negative a quarter and this is negative a half. So it is going to be there at the second one. Can you see? And at negative 3, this is negative 3.2, but you can also, I'll show you now another way, and this is going to be at negative a quarter. You can even make use of this principle that this is basically, and I think I'm going to illustrate it very nice here. This distance will be the same as this distance, which will make a 90 degrees there. Okay. So, but still you can plot it. So this is going to be negative 2 and 0. And then this one is going to be negative 0.8 and a quarter. And this one is going to be 1 and that half. And then you must label that. That's very important. And there you make the sketch. Okay. I want you to stop the video and I want you to do number 1. Again, you can continue the video as soon as you are finished. Okay. Okay, let's start. I think I'm going to make it a bit smaller. Okay. So if I look at number 1, the function f is defined, and I just use the other notation, but it's all right, the mapping notation. I can just go and I say for sin x minus 1, and they give me the interval. So x is bigger than equal to negative a half pi, and smaller than equal to a half pi. Now, if you can recall, this is also, as I showed you, now I'm going to take you back again to that word. It is the principal value interval of sin. I think I was showing it better here. Yes, here I told you. The sin one, where is the sin one? It's also that. The cost is between 0 and 180. So, okay, now let's go back. Okay, so it's also in that one. Now they say, state the range of f. Now remember, this is not a tan. So it's this one is making, the cos and the sin is making a curve. So the best will be for me to find, and I want to show you this. I think it's on the page stands there. Okay. I'm just bringing you back this page. You can recall, I wrote the page. Oh, no, I did not make the page. But it's on page, and I can just, page 160 in the textbook. Okay, this was on page 160. Okay, so I'm going to find in this question, I'm going to find the maximum value and the minimum value. Now, sin. Can you, okay, I can even make it a bit bigger. How did I find the maximum value? Can you remember? A plus c. How did I find the minimum value? Negative a plus c. Okay, So do you see, because it didn't exist there, I could use the other method there. But for this one, because it's a curve, I must now find the maximum and the minimum. Okay, so let's go back. We can, no, I don't want to make it so small. Let's just go and we bring it a little bit down. Okay, now I bring this also a little bit down. Okay, and there I can now start. Okay, so if I start with number A, I'm going to say, I know that this one is now, A is 4 and C is. So if I think of y equals A sin bx plus c. So I can see that therefore A is 4. Do you see that? And I can see that the value and C is negative 1. Okay, so I see that. Now I go on. I know that the maximum value, and what was the maximum value of the sin? It was, so the maximum value, oh, sorry, let me just see. That's the minimum value. The maximum value is A plus C. So A plus C, so it's going to be 4 plus negative 1, so that is going to be 3. And the minimum value, let's look at the minimum value, that is going to be negative A plus C, and that is going to be negative 4 plus negative 1, and that is going to be negative 5. So therefore, the range of fx, okay, because we're going to work with inverse also. So it's y is bigger than equal, put the smallest one there, and put the biggest one there. Okay, and that is going to be my range. Okay, so let's look at number B. Find the coordinates of the point at which the curve y equals fx intersects the axis. Okay, so I'm going to start, and this is now going to be fx. Now, if I want to find the x-intercept, I make y 0. Okay, so I'm going to say 0 equals 4 sin x minus 1. So 1 equals 4 sin x. And I divide 4 and I divide 4. Just move this. Let's just move up. So I'm going to get, okay, so therefore, sin x is equal to a quarter. Okay, but now don't forget my sketch. Oh, I don't like, I like to use a ruler. Okay, this is better. Now remember, this is blocked out. Okay. Now, if I must find my basic angle, remember, how do you find your basic angle? You just know, am I at degrees or am I in radians? I'm in, go back, I want to show you. You are in radians. So make sure your calculator is on radians. Okay, so let's just go. We press shift, sin, and bracket 1 divide 4, close the bracket, equal. I get that my basic angle is 0.2527. Make it four significant figures. Okay, so where is sin positive? Sin is just positive. There is negative, so sin is just positive here, and there is the angle. Okay, so therefore I'm going to get, so therefore x, let's get x, it's just going to be 0.253 radians. Read the question. Find the coordinates of the points of intersection. So therefore, the coordinate, x-intercept, let's just call it x-intercept. And I'm going to move it up. And this is going to be, okay, so it's 0.253 and it cuts the y-axis 0. So there is the x-intercept. Now I'm going to go on and I'm going to find the y-intercept. And now I make x 0. So again, I just do this. I can actually rather write y. So y is equal to 4 sin 0 minus 1. And you can just press it on your calculator. But if you say 4 multiply sin 0, I know it's 0, minus 1, so it's going to be negative 1. So therefore, move up. Therefore, the y-intercept, remember it's the y, so what's the value of x? 0, negative 1. Okay, and that was question B. See what's saying question C. Sketch the graph of y equals fx. Now I have quite a few information here. I can basically, let's see how can I sketch it. What do I have? What do I have? I also know the basic shape, but I think the best will be if I quickly create a table with what I have. Okay. So if I'm creating a table, okay. And now don't forget, this is my x and this is my y. Now don't forget you're going from negative a half pi. Let's make it then negative a quarter pi. And we make it 0 and we make it a quarter pi and we make it a half pi. And don't forget, you're just going to press it in your calculator to get these values. So if I'm going to start and I start pressing it, I'm going to say 4 multiply sin and bracket negative 0.5 multiply shift pi, close the bracket, equals, subtract the 1, and I get negative 5. Actually, I got it already. Okay, do you remember? Okay, but now negative quarter. Remember, every time I'm just, I move it a little bit down, I'm just substituting in here. Can you see? I'm just substituting in here. So now I'm going to say 4 multiply sin and bracket and negative 0.25 because that's a quarter, multiply shift pi, close the bracket, equals minus that 1, and that's negative, okay, negative 3, make it 1 decimal place. And then 0, actually we got 0 already. If it was 0, can you remember? It was negative 1. And now, so the next one, 4 multiply sin, bracket, and now 0.25 multiply shift pi, close the bracket, equals minus 1 equals. And this is going to be 1.8. And then a half, I think we have, but let's quickly do 4 multiply sin bracket 0.5 multiply shift pi, close the bracket, equals minus 1 equals going to be 3. Okay, so actually it's very interesting, and I'm actually glad that I did the table, because I did it, that just by putting the beginning and the end, you would have also come to the extreme values there. So it was not necessary to follow this method. You could have just put the interval negative, a half pi, and positive, and you also came to that. Okay, but now, if you make the sketch, okay, and I need a grid now, otherwise I'm going to struggle. Okay, so let's just get my grid. You're going to make your 1 centimeter blocks. So I'm going to, and I need a stronger color, blue also. Okay. Okay, so basically, I'm just going to make this as negative a quarter, negative a half pi, a quarter, a half. Okay, and then this can just be negative 5. I just want to see if I have enough. I must move it a little bit up. Okay, so I have negative, this negative 3, negative 4, negative 5. Seems to me I must go up to there. And that's 3. I think that one will fit. Okay, so let's start. Negative, and that was negative 5. So I think it was here. So 1, 2, 3, 4. No, 1, 2, 3, 4, 5. So luckily I checked because it was here. So 1, 2, 3, 4, 5. Okay. Then this one was, no, sorry, yo, pardon. Okay, let's just correct. I struggle because I'm not labeling it. And in this case, because I'm not doing the inverse, I can label it. Okay, so let's label it. Then I'm maybe not going to make so many mistakes. This is going to be negative a quarter pi. This is negative a half pi. And this is a quarter pi. Couldn't make it 2 blocks. And this is a half pi. This is negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3. Okay, now I used yellow, so now I used another color for my grid. Okay, so there it is. Oh, unnecessary. Trouble. Negative 3.8, so let's say approximately there. And then 0 and negative 1, approximately there. And then a quarter and 1.8. And then a half and 3. And if I do the nice, it's a curve. And from there on, it will do this. Okay. And that, don't forget to name it. So this is y equals fx. Okay, there it is. Okay, let's go on. Long question, long question. So sketch, I did that. Obtain an expression for the inverse, stating both the domain and the range of this. Okay, this is going to be, I think I want, yes. I don't like the grid when I work. So what I'm going to do in this case, I'm going to do it. I don't want you to do next to each other in exams, but for my sake, because I don't want to clean, it's still part of one question. So I'm just going to do it here. Okay. And that will be number, the last one, D. D. The inverse. Okay, so start first with the function. The function was fx, which is there. Okay, now I make it y equals 4 sin x minus 1. How do I find inverse? When I see a y, I make an x, and when I see an x, I make a y. Okay. Then I take this over, so x minus 1 equals 4 sin y. I divide 4, I divide 4. So I get sin y is equal to x minus 1 over 4. Now, can you remember how do I get this away? I'm just going to say, okay, so basically I make y and I make sin minus 1. Let me just swap this 2 sides. But I make sin minus 1, and then where the sin minus 1 stands, I think I'm going to rather, I rather keep the sin on that side and swap the 2. Okay, So I swap the 2. I say y. I make sin minus 1, and then I bring that 1 in. Did you see? So I put a minus 1, and I basically take this, and I swap it. Okay. And now I say, therefore, don't forget to write that. Okay, the inverse x equals sin minus 1 x plus 1. Oh, come on, please. X minus 1 over 4. I just want to see if it's x minus 1 or x. Oh, I see my mistake. Do you see it also? Because that was negative 1. Maybe you saw it already. Sometimes I like to just correct it here, because that negative 1 over and it became positive. Now, and I see it's incorrect. Okay, so if the negative goes over the equal sign, there was the equal sign, it just became a positive. And maybe you already picked it up, and that would have been very nice. Okay, and now they say write down the domain and the range. So what did they ask? Let's go back to the question. So, obtain an expression stating both the domain and the range of f minus. Okay, so we can just say, and we have it actually here. So the domain, let's start. The domain of f minus 1 x will be, will be this one's range, but you will write the x. So you will say x is bigger than equal to -5 and smaller than equal to 3. Okay, so that will be the domain, and the range of f minus 1 x will just be this one's domain. And this one's domain, can I just show you here? There was the domain. There was the domain. Okay, so basically I'm just going to say, and let's just go there. So the range is just going to be, I'm going to write it down, y is bigger than equal, remember its range, so minus pi over 2, smaller than equal to pi over 2. And that's